Hello, good people. Welcome to today's math class. Today we have this challenge before us here. The question is a radical equation, and here we have two equations. So how do we solve for the pair or pairs of x and y that will satisfy these two equations? Now, the first one is the square root of x all over y plus the square root of y all over x equal to 10 all over 3. And we're giving a second equation as x plus y equal to 10. So how do we get these values? Okay, so let's take our solution without much waste of time here. Now, if you look at the first equation, we want to rearrange the first equation. This equation could be written as the square root of x all over the square root of y plus the square root of y all over the square root of our x. This is equal to 10 all over 3. According to the properties of solid, that is what I just applied here, right? It says that if you have your square root of a all over b, then this could be expressed as square root of a all over the square root of b. Okay, that is one of the properties of solid. Then what we do here is easy. What is the LCM of this and this? The LCM is just square root of y times the square root of x. And there is another property of solid. We say that if you have the square root of a times the square root of, times b, this is same thing as square root of a times the square root of b. So if we are saying that the LCM of this and this is the square root of x times the square root of y, so we can rewrite it in this format. And so our LCM is going to be the square root of our x, y. Good. All right. Now we use the square root of this xy. So we take this denominator here to divide this. If we use this to divide this, we are left with the square root of x. We use it to multiply the numerator. And so this will give us, roll it where this is going to give us the square root of x all to the power of 2 there plus. So if you use the square root of x to divide the square root of xy, we'll be left with the square root of y. So we multiply the square root of y by the square root of y here. So up here, we also come up with bracket into the square root of y all to the power of 2. Everything equal to 10 all over 3. I believe no confusion here, right? Good. We know this power will go with this radical, this will go with this. And so we now have our x plus our y all over the square root of x, y equal to 10 all over 3. Now, what do you observe from here? We are having x plus y. Then recall our equation 2. I said, let's give this equation 2, then this equation 1. So what is our equation 2? Our equation 2 is x plus y equal to 10. And that is what we have here. So let's go ahead and substitute that in here. So we're going to have here, this now implies our 10 all over the square root of x, y. This is equal to 10 all over 3. Good. Now we are having this is equals to this. All we just need to do is just to cross multiply. So when we cross multiply, we're going to have this against this and this times this. So this will automatically give us 10 into the square root of x, y equal to 10 times our 3. Of course, we can divide by 10, divide this by 10. So this leaves, this leaves. So we now have this to be. So from here, we are left with the square root of our x, y equal to 3. What we just need to do here, because we want to eliminate this radical, so we square both sides of the equation, square this leaves. So we have our xy is equal to 9. Easy. Okay. Again, now we are having xy is equals to 9. From equation 1, we can make x or y the subject of the formula. So let's make y the subject of the formula. So say from equation 2, rather, this is equation 2, we are considering equation 2. We have our y, we want to make y the subject of the formula is equals to 10 minus x. Let's take this equation 3. So let's put equation 3 into this expression we have here. So this is going to give us our x into what is our y. We have 10 minus x equal to what? We have 9 here. So let's open up. This is going to give us 10x minus x squared equal to 9. Rearrange it, this will give us x squared, right? Then minus 10x, then plus 9 equals to 0. All I did is this. I moved this to this side. So if you move this to this side of the equation, it will become plus. Move this to this side to become minus 10x. Then here is already here with a plus sign. So we have plus 9. Okay? Everything equals to 0. This is a quadratic equation. So we solve this quadratically to get two roots to this challenge here. So we can use the factorization method here. We think of two numbers from the factors of 9 that when we add together will give us minus 10, multiply together will give us plus 9. And we know that the factors of 9, they are just plus minus 1, plus minus 3, and plus minus 9. So among there, we discover that our minus 1, minus 9 will give us this solution here. So we can have to rewrite this. So this is going to give us x to the power of 2 minus just x minus 9x plus 9, everything equal to 0. So we can bracket this, and also bracket this. What is common to here is just x. So x here will give us x, and minus, here we are left with 1. What is common to here and here is just 9. So we have minus 9, bracket 9 into this will give us x, minus times plus will give us minus, then 9 into 9 will give us 1, everything equal to 0. So you discover what we have here and what we have here are the same. So we take only one of these. So this is going to give us x minus 1. Then we take this and this. So bracket x minus 9 equal to 0. We apply the zero product rule. We say that we equate this to 0, equate this to 0. So we're going to have here x minus 1 is equal to 0, or x minus 9 equal to 0. So let's continue here. So I'll finish it up here. Okay, so we move this to this side. So we're going to have, therefore, our x1 is equal to positive 1, and our x2 is equal to positive 9. Okay, so we have our x1 and x2. Again, we have two variables in this challenge. So how do we get our y here? It's easy. Let's look at this equation. From equation 3, we made y the subject of the formula already. So let's get that from here. So we're going to have our case 1 when x is equal to 1. So we're going to have our equation 3, which is y equal to 10 minus x, which is 10 minus 1 is equals to 9. So we've gotten our y1 to be 9 already. Okay, so this is our y1. So let's look for our y2. We do same thing. We take that of our case 2 when x is equals to 9. So we're going to have our y2 is equals to 10 minus our x2. This x2, please. So we're now going to have your y2 is equals to 10 minus 9. So we have, therefore, our y2 is equals to 1. All right. Okay. So from here now, the pairs of the solutions, or the pairs of the values of x and y that satisfy this equation can be now written as our x, comma, our y now be equal to, what is our x1? We have here 1, comma, our y1, 9, right? Then for the other one, we have, what is our s2? We have 9 here, right, comma, 1. All right. So these are the values of x and y that satisfy the original equation. But can we do a check for this root if they will satisfy the original equation? Yeah, let's do a simple check to this. Check. So let's take a simple check to the first root here, the first pair, which is this. Okay, so what we do here now, let's take our equation. So we have the first equation, the square root of what is our x? Our x is what? 1 all over. Then our y is 9. Then plus, what is our y here? Our y is 9 all over 1 equal to 10 all over 3. Okay, again, like I said earlier, according to the law of sword, there we can split this to give us here the square of 1 all over, so the square root rather of 9, there plus the square root of 9 all over the square root of 1. So we have here 10 all over 3. What is the square root of 1? We all know that that is 1 all over the square root of 9 will give us 3 plus the square root of 9 again we have 3 all over 1 equal to 10 all over 3. The LCM of 3 and 1 is just 3. So we find their LCM to give us 3. 3 into 3 will give us 1. 1 times 1 will give us 1. So we have 1 plus 1 into 3 will give us 3. 3 times 3 will give us 9. Equal to 10 all over 3. If we sum up, this will give us 10 all over 3, which is equals to 10 all over 3. So this shows that the first pair of our answer satisfies the original equation. Again, if we change the narrative, we put in 9 here and 1 here, then 1 here, 9 here, it will still give us the same answer. And if we try that for our equation 2, what is our x? So let's put in 1 there. This will now be 1 plus 9. 1 plus 9 will give us 10. Or your 9 plus 1 will give us 10. So this shows that the two roots which we solve for satisfy the original equation. I believe you must have learned something from this video tutorial. Again, if you gain something from this video tutorial, give the video a thumbs up. You have a better way of solving this math challenge. You have a different approach, a different methods to solving this. Leave it in the comment section below so that Online Maths TV can equally learn from you. Thanks for being there. Thanks for watching Online Maths TV. Thanks for the encouragement so far. We love you. We love you. The best is yet to come. Do not give up on our channel. We are trying our little best to make sure that we dish out the best. Thanks once again. Keep watching Online Maths TV. We love you beyond explanation, beyond measures. Bye. But until we see you in our next video, keep winning. Bye for the now.